slope-intercept form, which is a really fancy way of saying the way we write the equation of a linear relation. And we want to write it in a way that is standardized or consistent so people can identify. Okay. And that form is y equals mx plus b, where m is the slope of the line and b is the y-intercept of the line. Hence why it's called slope-intercept form. In slope-intercept form, it is easy to identify the slope of the line and the y-intercept of the line because the slope is always the thing in front of the x and the y-intercept is always the thing not in front of the x. And we can identify them straight from the equation. So, for example, what are the slope and y-intercept of the relation y equals negative 3x plus 2? Well, here, the thing in front of the x is the slope, and the thing that's not in front of the x is the y-intercept. So the slope is negative 3, and I'm going to write it as negative 3 over 1 for myself, rise over run. And the y-intercept is positive 2. Positives and negatives make a big difference here. The slope and y-intercept of the relation y equals 5 minus 1 over 2x. Now this is a little bit backwards because the slope is always the thing in front of the x, and the y-intercept is the thing that is not in front of the x. So these are written in backwards order. The slope is negative 1 over 2, and the y-intercept is positive 5. Now, by having the slope and y-intercept easy to identify or to read, we can graph a relation without first having to make a table of values. So if, for example, I want to graph y equals 2x minus 4, I'm going to start by identifying the slope and y-intercept from the equation. So in this case, the slope is the thing in front of the x, it's a 2, and the y-intercept is the other piece, and it is a negative 4. That negative sticks with it. So once I have those pieces, I'm going to follow the graphing steps when you were given a point and a slope that we practiced before. I'm going to put a dot on the y-intercept at negative 4, and I'm going to use that slope up 2 over 1 to get my next dot. And repeat from that dot up 2 over 1, get my next dot, and I'm going to erase all my little bouncing lines here because I don't need them. Once I have 3 dots, I'm going to grab my ruler and I'm going to connect these dots to make sure they are all in the straight line. That's great. And I've graphed it without having to make a table of values at all. Let's try another. Graph y equals 1 over 3x minus 4, or plus 4. So the slope in this case is 1 over 3, is the number in front of the x, and the y-intercept is positive 4. So once again, I'm going to put a dot at positive 4 on the y-axis at 0, 4. I'm going to use that slope, rise of 1, run of 3, to get to my next dot. Rise of 1, run of 3, get my next dot. And erase all my little bouncy lines. Connect the dots with my ruler. And there we go. I've got a graph. Let's try one more tricky one. Graph y equals 2. Now here, I need to identify my slope and my y-intercept, but there's no x, which means I don't have a slope. What it actually means is the slope is 0, because 0 times x is 0, so we don't bother writing it in. So the slope is 0, and the y-intercept is the thing that is not in front of the x. It's the number 2. So I'm going to put a dot on the y-axis at 2, and I'm going to have a slope of 0, rise of 0, run of 1, and connect these dots, and I should get a flat horizontal line where all the y parts are 2. So using slope-intercept form, we can pretty quickly write the equation of a line from a graph. We need to identify the slope and the y-intercept, then put those values in the appropriate places in the equation. So if, for example, I have this graph here, and I want to write the equation of the line, I want to write it in slope-intercept form. So I'm going to need a slope, and I'm going to need a y-intercept. So my step 1 is I need to identify the slope and the y-intercept. So to do that, I'm going to put some dots at known corner addresses. I want to make sure I have one on the y-axis. I'm going to count my slope. I went up by 1 and over by 4, so my slope, which is rise over run, equals 1 over 4. And then the y-intercept, I'm going to read straight off the graph. It is that dot that crosses the y-axis. So in this case, it is the point 0, 1, or I can just say it's 1. And then I'm going to put those two values, the 1 over 4 and the 1, in their appropriate spots in the equation. Remembering that the equation in slope-intercept form goes y equals something times x plus something, where the something in front of the x is the slope, and the thing after the plus is the y-intercept. So this is going to be y equals 1 over 4x plus 1. And that's the equation of this line. Okay, I'm going to try a couple more here. So we're going to try writing the equations of the following relations. I'm going to look for the one on the left first. This one has a slope of 1 over 3, rise of 1, run of 3, and it has a y-intercept of 1 plus 1. So this is going to be y equals 1 over 3x plus 1. The second one on the right, this has a slope of -7 over 1. It's very steep. And it has a y-intercept of -4. Those negatives are really important. I'm going to put the slope in front of the x. And instead of writing plus -4, I'm just going to write -4. Okay, here's a couple for you to try. Pause the video and give these two a try. Welcome back. Okay, we're going to look at the one on the left. The one on the left has a slope. I've got two addresses there of 4 over 2, but that simplifies to 2 over 1, and I want it as simple as possible. And it has a y-intercept of +2, so the equation of this line is 2x plus 2. I don't usually bother writing the over 1 parts. The one on the right has a slope of -3 over 3, which works out to be -1, and a y-intercept of +4. This has the equation y equals -1x plus 4, or I could just write -x plus 4.